In this video, I will demonstrate how to check for Zener voltage regulation. How to check for Zener voltage regulation. Predicting the voltage regulation of a Zener diode voltage regulator circuit. Now, if you have a Zener diode regulator circuit, you need to have an idea whether or not the voltage will be regulated depending upon the supply voltage and the load. If the load is too heavy, in other words, if it draws too much current, there will be no voltage regulation. All right. Also, if the supply voltage falls too low, there will be no voltage regulation. So how do we predict that? All right, the steps. The voltage regulation of a Zener diode voltage regulator circuit may be predicted by removing the Zener diode from the circuit and measuring the voltage across the load. So if you were to do this in the lab physically, you would simply disconnect the Zener diode from the circuit, take a multimeter, and measure across the terminals where the Zener diode was connected. And if that voltage is greater than the Zener diode voltage, then you will get regulation. If it's smaller, then there will be no regulation. So if the voltage across the load is greater than the Zener voltage, then voltage regulation would result for that load and the associated supply voltage. Now, how do we do that? We use the voltage divider principle. The voltage divider principle is used to calculate the voltage across the load for a specified supply voltage, series resistor value, and load resistor. So we will now show you how to. I'll now show you how to calculate, how to determine, do the calculation to predict voltage regulation or not. Okay, so here we have a Zener diode voltage regulator circuit, and what we're going to do, I'm going to show you how to do the calculation. So let's start with some values. So let's say we had a supply voltage of, let's say 24 volts, and we had a series resistor, let's say of 200 ohms. 200 ohms. We just make up values here. And let's say we had a Zener diode was 14 volts. Let's say it was a 14 volt Zener diode. Okay. And let's assume that we had, let's say, a 200 ohm load. 200 ohm load. Okay. 200 ohm load. Now, looking at this circuit, we cannot tell right away if voltage regulation would result. So what do? The first thing we do is to disconnect the Zener diode. So that's out of circuit, right? And now if you disconnect it, you have, that would be our terminals, right? So this will be gone, and this is what we have. Now, if we do this physically in the lab, we take a multimeter and we measure across here, voltmeter, do on volts, right? If we measure here and we get greater than 14 volts, we know it will regulate. If it's less than 14 volts, it will not regulate. But how do we do the calculation? Okay, we can do it. Okay, we can measure it easily. But how do we do the calculation? To do the calculation, we are going to use a voltage divider method. So I'm going to redraw this circuit now in a form that looks easier, that's easier to understand. So if I draw the supply voltage, (24 volts), and we're going to draw our S series is 200 ohms. Okay, and we are following along this path, right, back to the battery. So at this point here, we would have, at this point, we would have our load, RL, which is 200 ohms. Okay, and Just going to clear the path here. So let's put this back here. 200 ohms. All right. So I will come back here, back to the load. All right. So here, across here, is where the Zener diode would have been. Okay. So this circuit here is equivalent to this circuit. All right. So we're going to disconnect the Zener diode, and we're going to do a calculation to determine what will be the voltage across the load. All right. So let me remove the Zener diode. Right. So I've just removed the Zener diode, and I want to find out how do we calculate the voltage. How do we calculate the voltage across the load? Okay, what's the voltage across the load? Right, so we're going to use the voltage divider principle. And so VRL, how do we calculate VRL? VRL is simply the V supply, 24 volts, multiplied by the load resistor, divided by divided by 200 plus 200. So VRL is equals to 24 volts multiplied by 200 over 400. And that works out to 12 volts. So this works out to 12 volts. Immediately you can see that 12 volts is lower than 14 volts. So in this case, under a 200 ohm load, this circuit will not provide voltage regulation. So let's do a quick calculation now for a different load. Let's increase the load now to 500 ohms. So let's say we have 500 ohms now. So we're going to calculate. Sorry about that. Oops, my pen playing tricks with me. VRL will be 24 volts multiplied by 500 ohms divided by 200 ohms plus 500 ohms. Let's remove all of this. Let's clean the board. Okay. So, okay, we are back here now. So remember, we changed that to 500 ohms. So this gives us 24 volts multiplied by 500 ohms divided by 700 ohms, and that works out to So 24 multiplied by 500 divided by 700 equals to 17.14 volts. 17.14 volts. So in this case, okay, you have 17.14 volts. You can now have 17.14 volts across here, across the terminals where the Zener diode has been removed from, and that would regulate because you will have a higher voltage than the Zener diode voltage. But what would happen is, under this condition, the Zener diode will always maintain 14 volts out across the load. Okay, you wouldn't get 17.14 volts out, right? That 17.14 volts allow the Zener diode to work and also supply the Zener diode to work in conjunction with the load. All right. So just to recap, how do we check for voltage regulation, potential voltage regulation? We remove the diode. On the lab condition, we will measure, but we want to calculate. So to calculate, we use the voltage divider method. So we take the supply voltage. So let me write that out. Actually, let me write that out in the generic form. So VRL will be equals to the V supply multiplied by VRL divided by the R series plus the RL. Okay, so to get the voltage across the point where the Zener diode is removed from, it is the supply voltage multiplied by, sorry, that should have been R, that should have been RL. Okay, VRL is equal to the V supply multiplied by the RL divided by the series resistor plus the load resistance. Okay, all right, so let's move on and let's do another example. Here we have a circuit where we have a 20 volt supply, a 100 ohm resistor, we have a 12 volt Zener diode, and we're going to check for regulation for a 500 ohm resistor. Now I would encourage you to pause the video and try to do it on your own. All right, so pause the video and try and work out to see if, do a calculation to see if this circuit would actually regulate. All right, so I assume you've paused the video, and now I'm going to do the calculation for you. All right, so we're saying we have a 500 ohm load. Okay, how are we going to check? We're going to say, all right, we're going to remove the Zener diode, and we're going to check for the voltage across the load. So VRL is equals to the V supply multiplied by RL divided by R supply plus RL. In this case, equals 20 volts multiplied by 500 ohms divided by 100 ohms plus 500 ohms, and that equals 20 volts multiplied by 500 ohms divided by 600 ohms equals, and you do that, do a calculation, 500 multiplied by 20 multiplied by 500 divided by 600, and that comes up to 16.67 volts. So with 16.67 volts across here, this circuit will definitely provide voltage regulation. Okay, let's try another one. Let's try a case where we have a 13 volt supply and a 500 ohm load. So we want to find out, will this circuit regulate? So we go through the same procedure again. All right. So again, we disconnect, and check for VRL. So VRL is equals to the V supply multiplied by RL divided by R supply plus RL. Sorry, R series plus RL. All right, so we get that VRL is equal to 13 volts multiplied by, we said the load was 500 ohms, right? Multiplied by 500 ohms divided by 100 ohms plus 500 ohms. That is equals to 13 volts multiplied by 500 ohms divided by 600 ohms. And that works out to, so it's 13 multiplied by 500 divided by 600 equals to 10.83 volts. 10.83 volts. So, with 10.83 volts across here, this circuit will not regulate. This circuit will not regulate. So we can put a big X here. Sorry. This circuit will not regulate. Okay? Because the voltage is too low. Right? All that you would get out of this circuit with 13 volts in and a 500 ohm load, you would actually get 10.83 volts. It would fall off from the regulated voltage of 12 volts down to 10.3 volts. All right, so that is how you check for voltage regulation.